from Microbe TV. This is Office Hours for Wednesday, October 1st, 2025. I'm Vincent Racaniello, and welcome to your viral corner of the internet, where you can ask any question you want about viruses and maybe a whole lot more as well. Good to be back. I've been traveling for 3 weeks. Got a lot in store for you tonight, so stick with us. Glad to see many of you are back. I thought you'd forget about us and not come back anymore. Let me thank our moderators here tonight. We have Les. We have Barb Mack from the UK. We have Tom Steinberg from Eugene, Oregon. And I know that Vanity Nutrition will be here because she just texted me saying how excited she was to be here. Yeah, it's been a couple of weeks, but we're back to office hours. I do have travel for the rest of the year, so we're going to miss a couple, but right now we're back and lots happening. So what do we have in store tonight? I'm going to show you some photos from my travels. Yeah. Just a few. I have a cool article from the New Yorker, an RFK Jr. satire. I'm going to read a little bit of that for you. We have some news. Lots been happening, of course. And then if we have time, I have a mini lecture queued up, which would be part 2 of the attachment and entry that we did part 1 of a long time ago. Seems like the beginning of September, right? Well, welcome everyone. Tell us where you are from. I want to shout you out here tonight. Let's see. Laura Potter is here from San Francisco. Thank you for your support of science communication. The Potters have been flu and COVID vaccinated. In fact, before I went on my journeys, I got flu and COVID vaccines. In New Jersey, you don't need a prescription. We'll talk more about that in a bit. And I bought a fancy mask, a reusable mask with a copper insert, and I wore it on the planes. And I didn't get sick. I don't want to get a respiratory infection. I'm of an age that is at risk, so I took those precautions. Viruses Luna is from Iowa. Welcome. Dagfinn is in Norway, where it's 8C at 2 a.m. The weather here is not bad, actually. Let's check it out, what it is. This morning it got really cold. It was 14C this morning, and tonight it's 16C. Looks like true fall is here. Speaking of Norway, I met a virologist from Norway at the meeting in Greece, and they're going to send an invite. He was from Oslo, so I'll next year possibly be going to Oslo. Dagfinn, we can hook up. 3 long weeks since the last one. Did you miss office hours? I didn't think you would miss it, but I'm glad if you did. Coralie is from Australia. Welcome, Coralie. Will is in Changsha, China. 33C today. They still have warm weather there. GSD Bio is Jonathan from Encinitas. Welcome. Kang is from Chicago. 22C with some clouds. Oh, you missed it. I'm glad you missed it. And we're back. I do pick up viruses from all over the world. Everyone does when they travel, right? But I'm very happy I didn't get sick. Says Leo is here from California. That's all I remember. Iris Luna says it seems HIV incidence is higher in 2024 than 2022. I don't know about that, but I can tell you that going forward it's going to get higher because of the cuts to funding of like USAID and PEPFAR. Here's an article from Tom Feline coronavirus 23 in Cyprus. Wasn't too far from Cyprus. Carol, our favorite nephrologist from Bakersfield, where it's 28C. Lovely. Leo is in Mendocino on the northern coast, 17C. Welcome. EHS Talent loved the immune episode about dental floss. Maybe interdental brushes would work better. They come in several sizes, could make them harder so they injure gums just enough to deliver the vaccine. Yes, that was published today. Very interesting stuff. And we'll see where it goes. Yeah. Thank you, Barb Mac. Good to be back. I actually got back. When did I get back? Oh my gosh, I can't even remember. Was it Saturday? No, it was Friday because I did. Was it Friday? Oh my gosh. Let me look it up. I have to look at my calendar. So I was gone. Yeah, I got back Friday because we did TWIB. I'm confused. Anyway, it doesn't matter. I'm back. Hat says, did you see Dr. Sete's new and groundbreaking study on ALS and its relationship to T cells? I did not. I will check it out, though. There you go. Vanity Nutrition is in the house. Our moderator. Thank you for coming. Ms. Blue Ocean is here, upstate New York. Brian Silverman is in Montreal, 11C and clear. Abdulaziz from KSA, welcome back. Betty K in Washington Heights. Windows are open. Yeah. Ms. Blue Ocean, the beautiful mountains and valleys of the southern tier of Western New York are starting to show their colors, even though we are in a drought. Rainey is having COVID rebound in eastern North Carolina, where it's 68F. Jason is in southwest France. I love the southwest of France. Used to go all the time. Mike and Lori are in Seattle, 16C. Artemis is in Montreal, 12C with clear skies. John, 24C in Minneapolis, which means we will have mosquitoes late into the year. Please, no West Nile. Legotic is in Chicago, 20C. And icy, yeah, I'm sorry. The ice business is just unacceptable. Elizabeth is in West Virginia. Hello. Raise 11 is waiting for weather to change, so more people are indoors getting infected before my flu shots. Why ask 27 Washington, D.C.? Send help, indeed. Hat is in San Fernando Valley, 76F. Jefferson Space, Miami. Your mask won't work with a beard. I got a mask that works really well with a beard because it wraps all the way around underneath. No problem. Do the copper inserts actually do anything? We do know that copper is antiviral, and so the droplets passing through the copper, you may get some inactivation. But, I'm mainly depending on the filtration of the droplets. Laura's in Washington, 18C and dark. Carol just returned from an Alaskan cruise where she escaped norovirus. There is an outbreak on another cruise ship. This is exactly why I will never, ever take a cruise anywhere. I don't want to get norovirus. The 2-bucket disease biology soon from Phoenix. Welcome. Hans from Ecuador. Nice to see you again. Brian is in Knoxville, Tennessee. Vista Tutti is in Sydney, Australia. Anna Hatamama. I like that. From Western Massachusetts. Cool. 6 is sick in bed with a minor bug in the Midwest. Hope you get better. 96 in Phoenix. Wow. Yeah, I wear my mask on the plane. There's too many people around. I wear it for the whole trip, and then in the airport, if there's a lot of people around, I'll wear it. So the Athens airport was ridiculously crowded. So I actually went outside to get to my check-in area because there's too many people. Too many people. SRR is from Paso Robles, 77F. John is in Tallahassee, 27C. Third day on Paxlovid. Feeling well. Excellent. I carried Paxlovid with me. I carried a dual flu COVID test kit and a prescription for Paxlovid. I was not taking any chances. I mean, we encourage this kind of behavior. I should do it myself, right? Clinton Global Initiative is stepping up for PEPFAR. Negotiated the new drug from $25K to $40. Yeah, that's Lanacapavir. Yep. Michael Schmidt, welcome to Office Hours. See you tomorrow on TWIM. Krishnan is in Malaysia. Good morning. Welcome back. Do I know West Nile vaccine? It's under development. Working on it. Oops, that's a bad word. Nope, can't say that. Christina is in Hershey, PA. 17C. Where did you get the copper inserts? Came with the mask. It's a certain brand of mask. I don't have it here. It comes with 2 copper inserts. They last a month on daily wear. Virus is Luna. In the hospital where I work, we had a few cases of West Nile neuroinvasive disease. Happens, yeah. Maureen is in northeastern Ohio. Here we go, Michael. Copper is antiviral. It's all about the tortuous path that the droplet aerosols need to contact with in order to disrupt the virus sufficiently to inactivate. It's all about the concentration. Thank you, Michael. Vincent, did you go straight to New Hampshire from Greece? No, I went to New Hampshire first. Oh, yes. I took a train back on Saturday and then Sunday flew to Greece. And then I got back on the following Sunday, and then Monday took a train to Philadelphia. Carol loves the immune episode on dental flossing a mouse, where I also talk about Frank Zappa song, Montana. All right. I'm sure there'll be more comments, but let's show some pictures from my travels. Let's see here. First up, this is the Harvard Virology Retreat. You can see there on the sign in front of the conference center, the Waterville Valley Conference Center. I took the train to Boston on Wednesday, stayed over, and then drove up Thursday morning with 2 faculty who were on TWIV. Lovely weather, lovely bucolic setting, great place for a retreat. Let's see, what's next here? Okay, so I did a TWIV, of course. Let's see if we can make this a little smaller. Nope, it's still right in front of an audience of mostly students, maybe 100 students. Very enthusiastic. So that's Aaron Schmidt. Tatum Sass, she's a graduate student. So Aaron is a faculty and the head of the virology program. Tatum is a G5, graduate student, year 5. And don't you love the last name? Sass? Oh my gosh, Tatum Sass. And Bernard Gewirtz, Ben Gewirtz, all the way at the end, another faculty who works on Epstein-Barr virus, and Aaron works on influenza virus immunity. I love this episode. You should go listen to it because we had great banter between us and the audience. I really enjoyed it. It's a lot of fun. I love doing live events more and more. They're really fun. Okay, what's next? So then Greece, this is flying into Athens at like 7 a.m. What a sunrise, right? Beautiful, just beautiful. And so I have to tell you this story. I don't have to, I guess, but I will. I fly to Greece. I take a taxi from the airport to the train station. I figured I'd take the train to Thessaloniki, which is 5 hours north by train. I see the countryside, right? So I get to the train station, which is this little building. There's like nothing. I'm thinking Penn Station. No. The train is canceled. It's supposed to be 10:30 a.m. The next one is 7 p.m. So I look at the flights. I say, yeah, I'll go back to the airport. No flight till 6 p.m. I didn't want to hang around the train station all day. I had luggage. I couldn't really walk around Athens. So I took a car. I rented a car, and I got there in time. And here is Thessaloniki. This is the view from my hotel. It's right on the water. It is gorgeous. The weather was just gorgeous. Absolutely gorgeous. And then this is the conference venue, right? Stage. The people talk here at this podium, and then these chairs were for moderators, and we did the TWIV from the chairs. This was the European Society for Clinical Virology in Thessaloniki. Every year it's in a different European city. Next year it's going to be in Porto, Portugal, and I'm really hoping to be able to go to that. That would be awesome. So on the stage, my two guests for the TWIV. It was a short TWIV, but I liked it. It worked. And of course, I also recorded some extra content. This was the audience for the TWIV. Some people didn't come. You know, there were about 500 people at the meeting. But these are the TWIV fans, so that's cool. I gave away lots and lots of TWIV stickers, Microbe TV stickers. Conference venue was beautiful. All glass. Beautiful sky. Unfortunately, the air conditioning could not keep up with this irradiation, and it was just hot everywhere. But it was okay. It was so beautiful. Here is a sunset from the conference center. It's just gorgeous, right? This is a major port, lots of ships coming in and out. And this is Mount Olympus in the distance there, right? Famous Mount Olympus. What else do we have here? And this is Elke Volkens. Wait, I forgot her name. Elke Volens from Belgium, this state health laboratory. And she talked to me about looking for viruses in plane poop, airplane poop. You should listen to it. It released today. So we recorded outside on the roof, which was a lot of fun. It was a beautiful setting. Okay, so this is a Greek piece of bread. I forgot the name, but it's native to Thessaloniki, and it looks like a big bagel, right? But you can't cut it and butter it. It's just not suited for that. But you break off pieces and you dip them in the nice sauces that they have. And it was delicious. And underneath that, of course, is a spanakopita, the spinach with pastry. And then next to it, the grape leaves, stuffed grape leaves. Oh my God, I love those. I love the stuffed grape leaves. And anything else here? So then Philadelphia, the textbook team got together for almost the last time to do finish revising. So we had a 3-day retreat in Philadelphia. And this day we took a yellow fever tour. So you may ask, what is a yellow fever tour? Well, Philadelphia was the setting for a yellow fever outbreak, the yellow fever epidemic in the 1790s. So the U.S. was already a thing. The capital of the U.S. was Philadelphia. The White House was actually in Philadelphia. And this plaque is in where the White House used to be. And slave owners escaping the slave rebellion in Santo Domingo or Haiti came to Philadelphia. They brought with them enslaved Africans, yellow fever. And then they had a big outbreak of yellow fever in Philadelphia, and we got a guide to walk us around and tell us all about it. In Philadelphia, we stayed at this Airbnb, which is basically a townhouse. We had all 3 floors with 5 bedrooms, each with a bath. It's really lovely, not too expensive. We had a kitchen where we worked, and I don't think I have a picture of that, but this is us having a drink at the Four Seasons, the top of the building in Philadelphia. That's the reflection in the building. And of course, this is Liberty Hall. And of course, I photoshopped in Theodora because she wasn't there. And that's it. Hope you like that. Kuluri, Vanity says. Okay, yeah, that's important. Kuluri is the bagel-looking bread. It's from Thessaloniki. Yeah, Kuluri, Artemis says. Yeah. Did you walk around the Agora practicing your Socratic approach to virology? That's great. I should have, right? Spanakopita. I like that. Yeah, I like it too. And then the dolma, the stuffed grape leaves. Yeah, really good. Okay, now in the latest or one of the recent New Yorker issues. Okay, this is the one with cover of Trump's hand holding a remote, and he can push any button he wants. But there's an article in this called RFK Jr. A Day in the Life. It's a satire by John Kenney. It's really good. I'm just going to read a couple of things. Upon waking each morning, I opened my drapes, removed the tin foil over the windows, and stared directly at the sun for 30 to 45 minutes until everything goes white and I can no longer see, which is when you know it's working. I'm not exactly sure what's working, but I know it is, and I know it's been proved. Sound familiar? Cheryl, which I presume is his wife, loves to drive, so I'm the passenger most days, but not in the passenger seat. Not a lot of people know this, but the inside of the car is more dangerous than the outside. So what I've been doing for some time is lying on a sled I've attached to the undercarriage of the car. People ask, isn't that dangerous? And I laugh because it's 10 times safer than inside the car. And they say, no, seriously, that seems incredibly dangerous. And I'm like, you don't get it. I literally have the study on my office desk or maybe in a drawer. And maybe it's a new study and it's out of Yemen and it disproves every safety feature that companies like Volvo claim is good for you. Yes, the Swedes are oddly beautiful, but they are known liars about safety. One more. This is great. Now, instead of coffee, I make a smoothie with protein powder, kale, wheatgrass, honey, a banana, 2 AA batteries, and a few pumps of WD-40. Several new studies have shown that petroleum distillates are hugely beneficial to humans. I have the studies here somewhere. Not only do I notice increased suppleness in my joints, but the hinge on the basement door no longer squeaks when I touch it. And on some days, I'm able to tune into a baseball game through my fillings. And it goes on. It's just great, right? It's just the way he talks. I have a study here. Somewhere here. All right, little news. Let's see, do we have any interesting comments? Frankie from Houston, Texas, 29C. Here's a link from Les. Brian Varner Clinton, Tennessee high school desegregation pioneer, just died. By the way, please press the like. We have 108 people here and 70 likes. Just hit the like. That doesn't make us any money. It just may attract more people here so they can find out what we're doing. Yes, we still need to do viruses in cats. Now that I'm back, we will work on that. No question about it. Jeff is from Elgin, Illinois. Clear sky and comfortably cool. Uriel asks, I'd love to get your insight on a question. How optimistic are you that phages could possibly be an effective solution to the rising problem of antimicrobial resistance? I'm pretty optimistic. We've done a couple of podcasts, including one from Australia where Jolene Ramsey went down there and talked to people who work on this. And, there have been some spectacular results, but a lot of work still needs to be done. I think for certain infections, topical infections, it will work well. I think it's harder to do a systemic infection, but people are working on it, and I think it'll be okay. Yeah, I'm pretty optimistic. Hello, Lise from Columbus, Ohio. Welcome. In Chang says in 1251, did your co-editors want to avoid Alan Dove's implication that cultured cells attend classical music concerts and stroll through an art gallery where cells and culture don't? No, uh, I don't think so. So we try to avoid saying cultured cells. They're cells in culture because cultured cells implies that they have culture. It's a little potentially misleading, right? That's the only reason we do that. So that's the New Yorker. Yeah, it's online. If you go to the New Yorker online, you can get, but you have to have a subscription, unfortunately. Brian says it was Greek fest in Knoxville. It had spanakopita. John writes, George Washington on the yellow fever plague reminded me about how he famously inoculated his troops with the controversial smallpox vaccine because he thought it gave them the best chance of winning. That's right. You know, he also left Philadelphia during the outbreak. Many, many people left Philadelphia to escape the outbreak. Eventually it subsided and they all came back. Hello, Questella. Kid had me on the wrong channel. Hello again. Nice to see you. Tom from Washington, D.C. is rather odd these days, but glad to be here. Instead of worrying about furloughed government science colleagues. Yeah, as you know, the U.S. government shut down at midnight today because our elected officials cannot get their act together and sign a document to keep funding the government. We send them there to do that, and they can't do it. And so many people are going to be furloughed, including lots and lots of scientists. Visto, phage design. Could phage also fight viral infections? No, probably not. The phage is a virus, so I don't think it's going to fight other viruses. Tom's job is okay, but could be. Well, good luck. Good luck. Okay, a few news items. I'm sure you have heard about these, but just in the interest of completion, let's talk about them. This is an article from Reuters, September 18th. As you may know, the Northeast United States formed a health alliance in response to the silly vaccine regulations coming out of the CDC. So 7 northeastern states, including New York, Pennsylvania, and New Jersey, and what were the other ones here? Connecticut, Massachusetts, Maine, Rhode Island, and New York City. These are all Democratic-led states. But interestingly, New Hampshire and Vermont are not part of this alliance. The license plates in New Hampshire, what they say, live free or die. That's from the Revolutionary War, but I don't know. I looked at it and I thought about anti-vaxxers. Anyway, the idea here is that this Northeast Public Health Collective or Collaborative, it's very much like the West Coast Collaborative, right? They're going to make their own decisions about vaccination, own vaccine recommendations. For example, they can say, like New York already did, you can get a COVID vaccine without a prescription. States are actually the last in line to make that determination. So no matter what the CDC says, the states can make their own recommendations. And so now this is an alliance so that multiple states can make their own decisions. I think it's a good idea. And so, for example, the coalition has agreed that updated COVID vaccines should be given to children 6 months to 18 years, older children and adults with certain risk factors, and adults over 64. So, I mean, this is because Washington is misguided and stupid about vaccines. They're just making stupid decisions. So these states are going to take it in their own hands. All right. So now what about the ACIP meeting, right? The Advisory Committee on Immunization Practices. Here's an article from CIDRAP by Chris Dahl from September 23rd. Infectious disease specialists lament chaos of recent ACIP meeting. So the ACIP traditionally makes vaccine recommendations. They are then approved by the CDC director, and then the states can adopt those recommendations or not as they see fit. And so, many infectious disease specialists are lamenting what happened at that meeting. For example, Helen Chu, ultimately what this meeting presented was a sense of chaos, a sense of lack of confidence in access to vaccines that are safe and prevent disease for the American public. For over 6 days, ACIP was regarded as the international gold standard for vaccine decision-making. Until recently, it was comprised of experts, including doctors, public health specialists, scientists, and expert in clinical trials, who carefully weighed the evidence and made recommendations for vaccines. But in June, these members have far less expertise. And they say it's not clear how the agenda items were chosen, why the committee decided to readdress two safe and effective vaccines, Hep B and MMRV. So, so what exactly did they do? Let's summarize that. So they recommended to discontinue the MMRV vaccine. So it's a combination: measles, mumps, rubella, varicella, right? 4 viral vaccines in one, for the first dose of kids. So first dose is 12 to 47 months. ACIP said you're going to get separate MMR and varicella. You can get them at the same time, but they should be separate. And why did they decide this? There's some evidence that there's an increased rate of febrile seizures after that first dose of the 4 different vaccines, and you don't see that when they're done separately. So that's why they did that. The second dose, which is given at 4 to 6 years old, you can use the MMRV for that because there's no evidence of febrile seizures there. And in fact, I think about 20% of U.S. parents only get the MMRV. Most get the MMR and then separately the varicella. So it's actually not a bad decision. Now, they were going to revisit the hepatitis B vaccine. There's no reason to revisit the hepatitis B vaccine. This is given to babies at birth because they can acquire hepatitis B virus from their moms during birth. And if they get infected, they will be infected for life. They cannot clear the infection. They establish a chronic infection, and that can lead to liver cancer. So the Hep B vaccine is incredibly important for preventing that. And these bozos don't realize this, these bozos on the ACIP. So they fortunately didn't consider it, but I'm just worried that next time they're going to drop it. And that would really be a problem. But of course, the Northeast and the West Coast alliances can say, we're going to recommend Hep B at birth, like we always have. So that means some states, probably red states, are going to drop the Hep B and blue states are not. Isn't that crazy? Health decision aligning with politics? Oh my gosh, I've never heard of such a thing. Sarcasm. One more story. I know this isn't virology, but for God's sakes, Trump says don't take Tylenol. He says MMR should be giving us 3 separate shots. Look what he said here. We want no mercury in the vaccine. There isn't any anymore. We want no aluminum in the vaccine. The studies have shown that it's not a problem. The MMR, I think, should be taken separately. This is based on what I feel, Trump said. It seems to me that when you mix them, it could be a problem. So there's no downside to taking them separately. In fact, they think it's better, so let it be separate. It's based on what he feels? Is that how you want public health decisions to be made? Over what a person with zero training in medicine or science and public health has? Oh my gosh, where are we? In Europe, people came up to me and said, "What is going on in your country? We never thought it would come to this." Oh my gosh. Anyway, there's really no evidence that acetaminophen causes autism. There are a lot of studies that have been done, showing no link. And a recent one out of Harvard and Mount Sinai showed there might be a small link, a link. It's not causation. And they said in the paper, this is not causation. It's a link, a very small link. And taking that, now the administration has decided to weigh against the use of acetaminophen. I'm sure many people in this live stream have thoughts about that. But as you know, one of the people who ran the trial was paid $150,000 to participate in that trial, and that's a very untrustworthy person. So acetaminophen has not been shown to cause autism. In the best studies, there's no link between the two. And the best studies have siblings, right, that you can compare with and without acetaminophen, because there it's the same family, the same mother. You can, as best as you can, eliminate confounding effects, where if you looked at a child in one family versus another, there are going to be all kinds of variables that are different. Science isn't based off vibes. Hunches are not grounds for solid science. That's right. The way you get people's confidence is to base decisions on science, not on what I feel. Strange times in this country, folks. Strange times. Let's see what people have to say about this. I'm just scrolling back. Here we go. Vanity says, if anyone is traveling, give yourself extra time at the airport. TSA employees aren't being paid from what I heard, and the security lines are very long. Good. Thank you for that advice. Appreciate it. John says he donated this week via the link on the screen. Thanks for another great week of programming. And I think I got my TWIP in on time this round. Vanity says, I'm surprised Vermont isn't part of the Northeast Collect. I am too. New Hampshire less so. But I'm surprised about Vermont. Bernie Sanders, come on. Shutdowns make government look inept, which is the plan. Yes, the government's inept, so let's destroy the government. Sure, and put a king in place. Folks, I don't know about you. I don't want a king, okay? I was fortunate to be born in this country. In the 1950s, we had no kings, and I don't want one now. No kings. GSD Bio tells us that phages can encode and display proteins or peptides that could be useful in vaccines. So in that sense, yes, you could use a phage to make a viral vaccine. Yes, I was thinking of phage therapy where the phage destroys the bacteria. It's not going to do that with the virus. But yes, this is a great application. Thank you. Elena, privyet, Reno, Nevada. Good to have you. And General Washington used variolation, not vaccination. Touge 410. I got my flu vaccine in Florida a few weeks ago. I wanted to get my COVID too, but my pharmacy didn't have any. Which COVID vaccine, if you can recommend? Well, I got the mRNA vaccine because that's what they had. I've gotten all my shots. How many have I gotten now? 3, 4, 5. The original 3 and 2 boosters. They've all been mRNA vaccines. I barely get any soreness in my shoulders. I had flu and COVID in both arms, different arms. Barely get any soreness, no fever. I'm lucky. Your mileage may vary. If you have severe local reactions to mRNA vaccines, search for Novavax, but it's hard to find. The United Northeast States, except Vermont, and Live Free or Die. That's right. Lagotic says, Lament Chaos will be the name of the first album from my new noise band named Motor Protein. That's a great band name. I love it. Artemis says Switzerland recommends COVID vaccine only for vulnerable people 16 years and older. The problem with that is that kids under 16 have died, right? 100 or 200, I can't remember the exact number. Now, you may say that's a small number, but not if it's your kid. Do you want to protect your kid? Yeah, I think, well, it's up to you as a parent, right? And so if you want to get it, you should be allowed to get it. Questella says, my autism has leveled up at least 1 million points since this all started. I can imagine. Yeah, yeah. That's great. Frankie says, I've seen a paper some years ago talking about stuffing nucleic acid into a phage head with phage displayed protein for targeted delivery. You could do that as well. Vanity Nutrition. Even Oz tried to walk back Trump's comments on Tylenol. It's just stupid. Just stupid. From the idiot who drinks how much Diet Cola. And this is what I was laughing at from Carol. If you just take Tylenol PM, your kids will only be autistic at night. That's a good joke. With MMR, does the live attenuated measles act as an adjuvant? No. If it's an infectious virus, you don't need an adjuvant. It multiplies and causes inflammation on its own. So it does not. Avi writes, constantly surprised Americans don't even think other countries exist and wonder what, say, European public health agencies are doing. Well, in fact, okay, that's a great point. I agree. Most Americans, until they go on vacation, they don't think other countries exist, but they like to go on vacation to other countries. One of my guests on the TWIV in Greece was a chief scientist at European CDC. European CDC is fabulous. They have a great website with lots of recommendations, outbreak tracing. I would go there. Of course, it's for Europe, so it doesn't help you here in the US, but it's really good. Of course, before 2020, the US CDC collaborated extensively with European CDC and other health agencies. It was all an international effort. It's only now that it's all being taken apart. Idiot was also talking about how much liquid's injected into babies. Yeah, he said that, 80 vaccines. I don't even know if that number is right, but even if it is, it's spread out over many years. Facts don't care about your feelings. Well, that's true. Hello, Julie from Denver. Kang writes, who trusts someone whose feelings bankrupted 3 casinos? Avi writes, rather, I think their plan is to ruin the cred and capabilities and expertise of the federal government to give everything to the states their dream. That's right. They wanted all the power decentralized, all the decision-making decentralized. That's correct. But, the way they're doing it is just pulling the rug out of agencies. That's not the way to do it. Nevitz, just coming from watching The Good Liars Talking Vaccines, interviewed MAGA's beyond crazy response to vaccines. Well, yes, they make no sense whatsoever. And when they can't answer you, they say you're getting money from Big Pharma. You're conflicted, which is all they can say because they can't say anything else. And that's not even true on its own, right? Oh, Vanity says, looks like Vermont had a timing issue and now they are part of the alliance. Go Vermont. Great to hear it. Tom got his flu and COVID vaccines. Luckily, the governor of Virginia has an emergency order to ignore Maha. Excellent. MN says, on a recent episode, you referred to vaccinia. That was Daniel. He said MMRV is vaccinia. And I waited a bit and then I corrected him. I said it's varicella. But yes, you're learning. You are learning. David B says, rotate the arms. You put the shots in over the years. There's fascinating evidence that local lymph nodes play a role. Well, there's a slight enhanced response if you put a booster in the same arm as the original vaccine. The ipsilateral arm, as opposed to the one on the other side, which would be the contralateral. That's just in terms of antibodies. Whether it makes a clinical difference, we don't know. But if you want, you can have it in the same arm. A quick Google search says thousands of kids under 20 have died from COVID. Thank you. So why would you not vaccinate those kids, especially if there are no severe vaccine-associated effects? And of course, the anti-vaxxers will say, more people die of COVID vaccines than prevent death. No, that's a lie. It is an utter, complete lie. Don't listen to them. MN says if there's a meme that illustrates that if Tylenol really caused autism, we'd have high-speed trains throughout the country. You know, autism was first detected in the 1930s, and acetaminophen was not really widely used until many years later. That's another thing. Martha from Charleston, welcome. Raise, since you know how, have you ever measured your antibody levels post-vaccine? I have not. Is there any correlation with soreness, post-vaccine fever, etc., with antibody response? I'm sure it's been studied, but those quick responses where you get the shot within 12 hours, you get fever, soreness, those are innate immune responses caused by inflammation. They're not antibody responses, which are going to happen a week to 10 days later. And yes, this is it, Frankie. They don't need to make sense. When people believe the mechanistic society doesn't provide for them, they go for the absurd option. That's right. And so, yes, people have had severe after effects of Shingrix. So Ray's 11 and Julie. I got 2 doses of Shingrix. Nothing at all, really. This is a tough question. Mateo, good night. How was your week? It was good. Well, the week is just in the middle, right? But so far it's good. Which 3 papers do you believe are the most important, you like the most in microbiology? So the Michelson and Stahl paper showing the mechanism of DNA replication is very important. The discovery of splicing in virus-infected cells and eventually in all cells, and the discovery of reverse transcriptase. I think those are incredibly important. There's so many more, but those are just coming out the top of my head. Guys want a mini lecture? I think so, because we're out of questions. But there'll be more. I know that. Yes. A nasty shingles vaccine reaction is better than having shingles. I had shingles when I turned 55. I had a band of rash across my upper belly, I guess. It hurt. I mean, I could take it, but you could tell, you knew it was there all the time. Yes. So they made CRISPR chicken. Yes, better cocktails and CRISPR chicken. When you can make people believe in absurdities, they can end up doing atrocities. Voltaire. Oh, yes. All of these things you folks come up with are just so lovely. Mini lecture. I'm approaching my Shingrix era. Yeah, when did I get it? No, I got shingles first before I got Shingrix. Got Shingrix only 5 years ago, actually, and I got Shingrix when I was 55. Okay, this is a very interesting question. Have your thoughts about the utility of the annual COVID vaccine changed over time? This is a really difficult question, right? Because you'd have to do a study. Let's say there's a new variant and you make a variant matched vaccine. Then you'd have to do a study where you compare people that got that vaccine with people who got the previous vaccine, but that vaccine is no longer being used. And you can't rely on people who got vaccinated with that last year because their antibodies have gone way down in the meantime. When you get a new vaccine, you get a nice boost of antibodies that last maybe a couple of months, and they will protect you from severe disease, but just for a few months. But whether it's long-term beneficial, we really don't know. So my logic starting on 3 weeks of travel, where I'm going to be among a lot of people, and normally, I guess I'm among a lot of people in the train station and on the train, but not as much as that. My logic was I want a boost of antibodies for the next 3 weeks. And for flu, I hadn't had a flu vaccine in 2 years, so I needed that. Of course, the circulating viruses are always changing, and we try and match them. But it's not clear for COVID how important that is yet. I chose to get it anyway, just to get a high titer of antibodies that would protect me from severe disease. Okay, that's the idea. Biology student had internal shingles. Wow. Shingles was the third worst pain experience of my life. And so does Tom feel the same way. Vincent's logic could be its own channel. I have a channel, don't I? This one. Do you think we'll really ever know what happened with COVID in Africa? No, I think the reporting was very poor, and so we won't. No. Let's do a mini lecture. I have one here. It's the part 2 of attachment and entry. And it's not very long, so we can get back to questions in a bit, maybe 20 minutes. So picking up where we left off that last time, we were talking about how the nucleic acid gets out of a virus particle and into the cell, all right? And last time we talked about influenza virus uncoding, where the virus comes into an endosome, the pH begins to drop, and then the hemagglutinin undergoes a conformational change and triggers fusion. So the virus and the cell membrane fuse, and out come the influenza virus RNAs. Another example I wanted to give you is SARS-CoV-2. SARS-CoV-2, of course, is an envelope virus with spike proteins on the surface. And those spike proteins bind the receptor ACE2. Here is the spike protein on the right. It's three-dimensional structure, and it has a domain called the RBD, the receptor binding domain, and that interfaces with ACE2, which is the cell receptor. All right. So the virus binds the cell surface receptor. Let's look at the panel on the right. In respiratory tissues, when the virus is bound on the plasma membrane, in the cell, there's a protease called TMPRSS2, TMPRSS2. And that protease will cleave the spike, which is needed for it to catalyze fusion. Once the spike protein is cleaved at this site right here, it's marked S2 prime, then the spike protein unfolds, and the fusion protein is pushed towards the membrane. So normally the fusion protein is shown here in cyan. Normally is buried. But once the spike is cleaved, the fusion protein is thrust towards the membrane, and that catalyzes fusion at the cell surface. So that's how SARS-CoV-2 gets into cells, at least in the respiratory tract. Now, early on in the pandemic, a lot of people flooded into the field, started working on SARS-CoV-2 because they knew there would be money to be had, grant money. And a lot of people used kidney cells, vervet monkey kidney cells, which is a standard cell line that's used by a lot of virologists because you can grow many different viruses in it, including SARS-CoV-2. Unfortunately, in those cells, those kidney cells, the virus does not enter at the surface. There's no TMPRSS2 on the surface of those kidney cells. So the virus is taken into an endosome, and in the endosome, a protease called cathepsin L cleaves the spike, and then the fusion occurs. So the RNA comes out of the endosome as opposed to respiratory tissues where it comes out at the cell surface. Why am I telling you this? The people who discovered the antiviral effects of hydroxychloroquine did their experiments in vervet monkey kidney cells, or Vero cells. And so there the entry occurs from the endosome. And in fact, hydroxychloroquine inhibits the activity of this protease cathepsin L, which cleaves the spike, and therefore it inhibits virus multiplication. But hydroxychloroquine has no effect on lung cells where the entry is at the surface because hydroxychloroquine does not affect TMPRSS2. So if you knew anything about the biology of SARS-CoV-2 entry, you would never approve hydroxychloroquine, which is what happened in the US without any clinical trials. The FDA just said, use it, gave it an EUA, emergency use authorization. It didn't help, and it harmed a lot of people. They didn't bother to look at the basic biology of what was going on, which is shown here and makes it very clear. Hydroxychloroquine had no chance to inhibit infection. And I don't want to hear any hand waving or anything. It's end of story, period, full stop. No chance, ever. It was a stupid decision, forced by the president, told the FDA, you got to approve this. And that's why it didn't work. Okay, moving on. We've been talking so far about class 1 fusion proteins. Now let's go back. What is a class 1? It is a trimer. It's perpendicular to the membrane and a lot of alpha helix structure. Class 2 fusion proteins are mostly beta sheet. What is a beta sheet? It's another kind of protein structure. Here, these little arrows, the black arrows, they're beta sheets compared to helices, which are these coils. Mostly beta sheet. They make dimers, not trimers. And they're parallel to the membrane. So here's a flavivirus with the glycoproteins laying flat on the membrane. Again, compared with SARS-CoV-2, where they're sticking perpendicular to the membrane. Nevertheless, they can still function in fusion. They're here in panel B. You see the glycoproteins are parallel to the membrane. They're a dimer, right? As the virus enters the endosome, the pH drops. These laying flat glycoproteins extend, and they push the fusion protein into the membrane, and eventually you get a pore formed so that the viral RNA can come out into the cytosol. So that's how class 2 fusion proteins work. And there's also class 3, but we're not going to cover those tonight. So here's an animation of dengue virus entry. That's a class 2 fusion protein where the glycoproteins are flat on the surface. And you can see as the endosome is moving into the cell, it's acidifying, and those glycoproteins are going to stand up. Boom. And the tips have the little fusion peptide, which is going to insert into the endosome membrane. You can see that happening right there. And then the fusion proteins do what's called hairpinning. They go back to their native conformation. And so they're pulling the membranes together, the endosome and the virus membrane. And once you get two membranes really close and get rid of all the water molecules, they will fuse, is what's happening here. And then the viral nucleic acid can come through the pore and out into the cytoplasm. There it is, coming out of the virus particle. Boom. Start a new infection. Gotta love it, don't you? That you can see what's happening by these animations. Yeah, they're brilliant. What else we have? Ebola virus entry. This is a new way of viruses getting into cells, discovered just, I don't know, maybe 10 years ago. Ebola virus are these long filamentous particles, right? They attach to receptors in the cell surface, and they're taken into an early endosome. The glycoprotein is cleaved in the endosome, and now you have a glycoprotein which can bind a fusion receptor in the endosome, which is called NPC1. And that binding allows the virus membrane to fuse with that of the endosome, and out comes the viral RNA. This receptor, NPC1, is Niemann-Pick cholesterol transporter. This is a transporter that's important for balancing cholesterol in the cell. And there are people who are born with genetic defects in the gene encoding this transporter. They don't live past 11 or 12 years of age. The defects are too serious. But cells from those patients are resistant to Ebola virus infection, showing that that is the endosomal receptor for infection. Now, this is unusual because the fusion receptor is in the endosome. It's not on the surface of the cell. Now, all the examples of fusion that we've talked about, what's important to get from it is that fusion is regulated. And what I mean by fusion, it's not a kind of cuisine. By the way, in Philadelphia, I went to a restaurant called Budokan. Fabulous Asian fusion restaurant. Oh my God, if you're in Philadelphia, go to Budokan. Fusion is regulated between a virus and a cell membrane. Why? You know, virus particles are floating around in your fluids, and they can't just fuse when they bump into any old membrane. It has to be the membrane of the right cell, right? And so some viruses fuse at the plasma membrane, but there have to be, usually there are two receptors that have to interact from the virus to the cell to catalyze that fusion to make sure it's the right cell. Sometimes fusion happens in endosomes catalyzed by low pH. You have to have proteolytic cleavage to activate the fusion protein. Those are class 1 fusion proteins, and that adds another level of specificity so that you're only going to get in the right cell. And of course, for Ebola viruses, there's an endosome fusion receptor that regulates fusion as well. So fusion is always regulated for the reason that the virus needs to fuse only with the right cell. What's the wrong cell? The wrong cell would be a cell where the viral genome cannot replicate, and so it's wasted. Unfortunately, waste happens a lot in virus infections. That's why viruses make so many particles, because so many infections fail. You know, you think, sorry, that was a quiz left over from the students. Actually, maybe you should take it. Viral fusion peptides are exposed for insertion into the host cell membrane when A, the virus particle is near a cell, B, the virus particle is in the cytoplasm, C, trimers of the fusion protein form, D, the endosome becomes acidified, E, the virus is docked onto the nuclear pore. Think of this as Jeopardy, just a one-question Jeopardy. Which is the right answer? Viral fusion peptides are exposed for insertion into the host cell membrane 1. Let you think about it for a while. There's only one answer. GSD Bio is the first to answer D. The endosome becomes acidified. That's right. Visto said B. Dagfin said D. You can keep answering because there's a delay. So being near a cell is not going to expose the fusion peptides. In the cytoplasm, well, it's kind of late, right, to do that. Trimers of the peptide form? No, there are already trimers on the virus particle before fusion. When the acidification is what exposes the fusion peptides for insertion into the host cell membrane. And of course, the nuclear pore is much too late. Hey, man, I should leave these quizzes in here for you guys. You're good. How about non-envelope viruses? So we talked about so far viruses with membranes. What about adenovirus, where there's no membrane? It's just pure protein, right? There's no fail, folks. You know, you're just hearing this for the first time. It's hard to do a quiz. Just rejoice in your wrong answer because you learned something from it. I've been doing these video exercises for neck pain, right? And the guy says, rejoice in your pain. You're going to conquer it. Rejoice in your misfortune. And that's a pretty heavy ask, isn't it? But anyway, rejoice in your wrong answer. Here's adenovirus. It's a non-envelope virus made of pure proteins. It binds to a receptor on the cell surface. Then it's taken into the cell after binding to a second receptor, which catalyzes the internalization. So the membrane forms around the particle, the endosome, and then it moves further into the cell, starts to become acidified. When the pH drops, the particle starts to become disassembled, and there's a single protein in the particle. It's these little yellow diamonds that maybe you can see there. With the acidification, they leave the icosahedral particle and they insert into the endosome membrane and they rupture it. So then the particle can get out. This particle is still quasi-semi-intact, okay? Then the particle binds a microtubule and is motored down to the nucleus where the virus docks onto the nuclear pore, and then the DNA comes out. How the DNA gets out is very interesting. I think it's in the next slide, but let me just show you some electron micrographs first. So here's an electron micrograph of an adenovirus particle riding a microtubule. See, right down, that's how virus particles move around cells. They don't just diffuse, okay? And here are a couple of adenovirus particles docked onto the nuclear pore. So we have good evidence for all of these stages. So here's how the particle is disassembled. So remember, we have adenovirus partially disassembled. It's riding down the microtubule. It docks onto the nuclear pore. And how does it ride down the microtubule? By motor proteins. There are motor proteins that go in one direction towards the nucleus, and there are motor proteins that go the other direction away from the nucleus. Once the ad particle is docked on the nuclear pore, the motor protein binds to it that goes in the other direction. But the virus is stuck on the pore, so what happens? It breaks up. Breaking up is hard to do, but adenovirus figures it out, and the DNA then can be imported into the nucleus. So that's really cool how that uncoding works, isn't it? Don't you love it? Oh, the ingenuity of nature. Here's an example of poliovirus, another virus without a membrane, a protein shell. It binds to its receptor, and the receptor catalyzes the rearrangement of the particle to introduce a pore into the virus particle. And the pore is through which the viral RNA gets out into the cytoplasm. And here is a cryo-EM structure of the particle with this pore form. So these little feet here would be, the membrane. And here's the proteinaceous pore caused by interaction of the receptor with the particle, and then the RNA is going to come out here. So this would be like these funny extensions here would be like the endosome membrane, and the RNA would come through the pore. And there's a view of the pore there on the left. So the receptor does this. It's the virus receptor that catalyzes the formation of this pore. The same thing happens with the calicivirus. So here's a calicivirus. It's an icosahedral particle, and upon binding of the virus to its receptor, a pore forms in one part of the particle. You can see you're looking down on it here and from the side here. So again, just like poliovirus, the pore is catalyzed by the binding of the receptor. What's interesting, and it's written down here at the bottom, for poliovirus and calicivirus, only one portal is formed. That's what we're calling these pores, portals. How does it know where to put the portal? Because remember, the RNA is a long single-stranded RNA with just two ends. And those are the only two ways that the RNA can get out of the cell, by an end. Can't get out from the middle. So how does it know where to put the portal? It probably doesn't. There are 12 potential portal sites on the virus particle, and they're probably all tried, and 1 out of 12 works. The other 12 don't work, and again, virus infection fails. So that's the thing with viruses. And someone said it really nicely in the comments here. We'll get back to the comments in a bit. But yeah, viruses make a lot of mistakes. That's why they make so many offspring. All right, where's the darn? Here we go. I lost my thing here. Okay. So that's calicivirus and polio. Reovirus is an interesting story. It's also an icosahedral capsid with double-stranded RNAs inside, but there's two capsids, actually. There are two shells. So the virus attaches to the shell, gets taken up by endocytosis, and as the endosome fuses with the lysosome, remember the lysosome has enzymes in it, the enzymes remove the outer shell, and that exposes these turret proteins, which are shown in green, which allow the particle to pop out of the lysosome into the cytoplasm. So those green turrets, you can see them here in this side view. Those are the green molecules here. And you see they're protected by the outer shell, but this outer shell is removed in the lysosome. It exposes the turrets, and then the turrets can cause the particle to get out of this vesicle. And then mRNA synthesis will occur after that. So many clever ways. If we can say that it's a clever way, because we know viruses do not have any feelings whatsoever, but looking at it as a human, it's pretty damn clever. So here's a summary of all the different ways that viruses can get into cells. They can bind at the plasma membrane and fuse, and the capsid in this case gets in. It's taken to the nucleus by motoring down microtubules. We talked about adenoviruses becoming endocytosed, partially disassembled, and motored down to the nuclear pore. Some viruses get in by endocytosis. There are many different kinds of endocytosis. There's clathrin-dependent, there's clathrin-independent, there's caveolin-dependent, just different proteins involved, but they all involve taking up the particle in a vesicle, the pH dropping, and eventually the nucleic acid of the particle getting out. The last step for many viruses is getting into the nucleus. And here are 4 ways that happens. First, for influenza virus, when the RNAs of the virus get out of the particle, they can actually fit through the nuclear pore. They're small enough. So they're simply imported into the nucleus, which is where they replicate. Remember, herpes virus has a single portal on the virion. The portal docks onto the nuclear pore, and out comes the DNA. It's inserted into the capsid under high pressure. So as soon as this portal opens up, in goes the DNA. That's the sound it makes when DNA comes out, by the way. We talked about how adenovirus is partially disassembled and broken as it's pulled in the other direction, and then the DNA gets in. And then interestingly, the parvoviruses, the adeno-associated viruses, they attach to the nuclear pore, and then that causes a disruption in the nuclear membrane. And so those particles get in the nucleus where then the DNA gets out. So lots of different strategies for getting your nucleic acid where it has to be. Last story is about receptor polymorphism and susceptibility. This is about rhinovirus receptors. So there are three different kinds of rhinovirus receptors, okay? And the rhinoviruses are divided into A, B, and C genotypes. And they can bind three different receptors. So the rhino A and B, 90 serotypes of those bind ICAM1, which is this molecule here, and 10 serotypes bind the low-density lipoprotein receptor. And then we have 49 genotypes, actually many more, of rhino C. They bind this protein, CDHR3. And CDHR3 is shown on the left particle. That it binds perpendicular to the particle, whereas LDL receptor binds on the surface. Sorry, on the left is ICAM1, and on the right is LDL receptor, low-density lipoprotein receptor. So here's CDHR3, and how it binds the particle, we're not quite sure. It seems to wrap around it, right? But the story begins with an amino acid change in CDHR3. So remember, this is a host cell protein. And an amino acid change at amino acid 529 of CDHR3, the presence of a tyrosine. So normally it's a cysteine and it can be changed to a tyrosine. That change, that genotype, is linked to increased risk of wheezing illnesses and hospitalization for childhood asthma. So kids who have a lot of wheezing illness and childhood asthma, they're more likely to have a tyrosine at 529 amino acid of CDHR3. And what we think happens is that amino acid leads to higher surface level production of CDHR3, and you have, as a consequence, increased rhinovirus binding and increased yields of rhinoviruses. And that is what causes the wheezing illnesses, because you get rhinovirus infections that are more severe. Okay, so that's important. That polymorphism from C to Y is associated with more severe disease. In 2013, there was an outbreak of rhino C in chimps in Uganda. And they got the virus from humans who were visiting them, right? All the chimps were genotyped as 529Y, the allele that gives rise to more severe rhinovirus infection. In fact, many of these chimps died as a consequence of rhinovirus, which would usually not kill a human. Only humans have 529C, actually. Neanderthals, Denisovans, chimps, they all have 529Y. Now, the chimps rarely see rhinovirus C, so there has been no opportunity for selection of C, which would reduce the pathogenicity of rhinovirus. Only humans have encountered rhinovirus long enough to have it been a selective force in selecting for CDHR3 with a C at position 529. So that tells us that rhinovirus has likely emerged during the onset of Homo sapiens, when there were no Neanderthals or Denisovans around, or very few, because they still have Y, and there was no opportunity to have selection for Neanderthals or Denisovans with a C, which would have milder disease. So a single amino acid has huge implications in terms of the pathogenicity and the evolution of this particular virus. All right. I really like virus entry because I worked on poliovirus receptor. My lab worked on poliovirus receptor for many years. We discovered it. Kathy Mendelson in my lab identified it. And so I like the field. All right, let's go back to the beginning where we left off. Lot of questions. It's great. Okay, here we go. like a side channel of sorts. Okay. I don't know what you actually mean, but don't worry about it. And here I get this from Will. Boiling water poured over my side day and night for 6 days. I don't know what he's referring to. It doesn't sound pleasant. What chapter are we in? Oh, sorry, Costello. I didn't see that before. That would be chapter 5 in the book. It's all in there, except the rhino and chimps. The full lecture is here. That's the link. Biology could listen to this all day. Oh, that's so nice. I love talking about all this. Peter loves the mini lectures. Thank you very much. Vincent's logic is very straightforward. I have done this so long. I figured out how to teach it properly, I think. Yes, many of these. So coronaviruses have super long helices in the spike, but so do many others, especially in the fusion conformation, right? This is a good question. Any thoughts on the Canadian government's planned culling of ostriches on a British Columbia farm? So the last bird died in February. I think it's highly unlikely that the others are still infectious. Flu is not going to cause that long an infection. They should just check them. The farmer doesn't want to check them because the government says we'll check them, and if they're positive, we're going to kill them. So the farmer says, then you're not checking them. But I doubt they're infectious. Because I love you. Well, I don't know what the first part of that was, but of course I love all of you. I love all of you. What's the link between TMPRSS2 and prostate cancer? I don't heard about that. Let's look it up. Yeah. So the TMPRSS2 fuses, the gene fuses with erythroblastosis oncogene that leads to the overexpression of the oncogene and promotes cancer. So TMPRSS2 gene fuses with the gene of an oncogene, causing overexpression of the oncogene, leading, to prostate cancer. There you go, Laura. Good question. Beta sheets, kind of like corrugated roofing. Yeah, that's a good way to look at it. Yeah. What protease inhibitors bind TMPRSS2? Camostat is a known inhibitor of TMPRSS2. But after the hydroxychloroquine fiasco, which I think it's fair to call it, nobody wanted to do the right tests on Camostat. So we never used it. John wants to know any thoughts on azolastine. So Daniel talked about this on Clinical Update. And there is a modest effect on COVID by azolastine. And he said it was modest, and he doubted that he would use it. But if you're on it already, maybe it's going to have a moderating effect on disease. What triggers TMPRSS2 to do the cleavage? Just the binding of the spike. The spike binds to TMPRSS2 in the active site, and it just cleaves. Why is it so cute? What is so cute? So this is a while ago. I'm sorry, Questella. Yeah, so that's why I showed you that, showing the initial study was flawed. It was done in a cell type that's irrelevant for a respiratory infection. It's a kidney cell. Do it in a respiratory cell, folks. It matters, but if you're not a virologist and you're coming in the field to study SARS-CoV-2, you're going to make stupid mistakes like that. Talk to a virologist. You know what, Will, and all of you others? Expertise does matter. This idea from Trump and RFK Jr. that we don't need experts, we can figure it out. Baloney, you can't figure it out. You don't know what you're talking about, actually. I spent 40 years to get moderately smart about viruses. I don't know everything. Nobody does. but smarter than Trump and RFK put together and all their cronies. They don't know anything. But as we've said in the comments, they don't have to know anything. Boom. Yes, I like to say boom. Somebody else did that. Somebody else, some broadcaster did that. Did we know this biology when it was approved? It was never approved. Hydroxychloroquine was just given an emergency use authorization. And yes, we knew this. But Trump and the FDA director didn't bother to look. I'm glad the FDA didn't approve the president's idea about injecting disinfectants. Okay, so here's an extension of that story. So Trump makes the FDA director approve hydroxychloroquine or give it a EUA. And it goes all wrong. Okay, so towards the end of 2021, the vaccines have been tested, right? I think that's the right time. And maybe it's 22, but anyway, Trump pressures the FDA director to license the vaccines before the safety studies are complete. And the FDA directors, and that's because he wants the vaccine out before the election. So that would be 2020, right? And the FDA director says, no, I am not doing that. I'm waiting for the safety studies to be through, which took it past the election. And that was the right thing to do. We do not alter science for politics. At least we shouldn't. If you do, look what goes wrong. Oh, Daniel did not like the hydroxychloroquine EUA. There was no evidence that it would work. Yes, he was very critical early on in the earliest clinical updates. Yeah. So sorry, Frankie, you were the first to get the answer. So here's GSD Bio down here. And Frankie was first. So Frankie was the first. Then we had GSD Bio, we had Visto, then we had Dagfin. And here is the comment, and then Laura got it, and Biology soon. So viral infection is like carpet bombing. Many failed hits, but one makes it into the right cell. That's it. That is it. Carpet bombing. Yes. You know, you got B-52s way up in the miles up, dropping bombs. Who knows where they're going? Maybe one will hit a target. That's what viruses do. Yes. Because a lot of them just don't work. Tens of thousands of particles made and just a few will work. Yeah. All right. I'm going to leave the quizzes. Well, actually, there aren't any. I don't think there are any mini lectures left. Well, unless we do new ones like cat viruses and other stuff. But I'll put quizzes in. Yeah. Yeah. I'm sorry, Frankie. I don't know why I didn't see it originally, but yeah, you got it right. Become one with the universe. Rejoice in your failure. Yeah, rejoice in your wrong answer because at least it means you tried, right? I really like that idea. Don't say I failed, right? You tried. Now, actually, you learned something because I explained what the right answer was and why, and so you've learned. So there's no fail. Frankie says, I do study viral proteins, not capsids, so me answering is kind of cheating. Getting it wrong would be embarrassing, though. Yeah, but you know, Frankie, people are so specialized these days. But yeah, a structural biologist should probably know the answer to that. We got the rock band Motor Protein playing in all of our cells. You can hear it if you just get quiet and close your eyes, you know, and just eliminate all extraneous sounds. You can hear Motor Protein playing. Yep. Breaking up is hard to do, but adenovirus has figured it out. Exactly right. It's very cool. I love it. I love it. All the different strategies for entry are just brilliant, right? It's even more interesting to know why a pH drop causes the protein to change conformation. Everything goes back to chemistry. In fact, Nevitz, it's all about thermodynamics. Everything. Me talking here is all about thermodynamics. Yeah, chemistry, but chemistry is ruled by thermodynamics. Yes, this stuff could take someone years of work just to get the protein to be stable enough to make crystals, right? This is all done by crystallography, although now we can do them by cryo-EM. Lagotic wants to be an adenovirus. Why is that? Leo is the lead singer for Motor Protein Gene Pool. Yes, exactly right, Gene Pool. Sean says, I hope Dr. Amy is doing okay with the government shutdown thingy. Good luck to all. Yeah, we'll have news soon from Dr. Amy. It's staggering to even try to have a basic grasp of this without studying for years or decades, and then jarring to see administration make recommendations of feelings and vibes. Yeah, I got a feeling about this. But all the stuff I told you in that lecture took decades to figure out, and it's all useful. And so you take NIH research money away from what do you think you're doing? You're impeding future progress. It's just stupid. Many previous administrations have seen the wisdom of supporting science research in this country. And why can't you? Because you let racist people take over the government. That's why. Who think only certain kinds of people should inhabit the U.S. And of course, you want to give tax breaks to your rich buddies. Frankie, what about naked viruses? Well, I gave you some examples of naked viruses: poliovirus, calicivirus, adenovirus, and reovirus, right? Hypoviruses. Well, many fungal viruses are not encapsulated at all. And maybe that's what you're talking about there. So they don't have to worry. They just multiply, and then they're partitioned among the dividing cells in the end. Yeah, I understood you meant capsidless, but I used to call them naked. Yeah, I still do. Hello, Ripticomp. There's no Dr. Rosenfeld here. I didn't see her anyway. Maybe she is. Is the lysosome a kind of cell defense? Actually, it could be. So normally the lysosome is recycling stuff from the cell surface, right? And also breaking things up. But yeah, most viruses escape the lysosome fusing with an endosome because they would get degraded, except reoviruses. They stay in because the lysosomal contents actually take off the outer shell of the reovirus, right? Extremely smart for them to get out. Frankie, I remember reading about RVC after hearing it from one of your lectures. JJ says, viral entry seems elaborate. Do you know how the mRNA in the vaccines enters cells? Yeah, it's the lipid coating. They fuse with membranes. My understanding is they could fuse either at the plasma membrane or it could be taken up in endosomes, and the lipid membranes simply fuse. They don't even have fusion proteins in them. Visto says, I wonder if all the viruses us dirty humans carry have a role in extinction of Neanderthals. I think we killed them. Basically, we fought against them and killed them because we're nasty humans. Homo sapiens are nasty at the core. But they could have given them diseases, like Rhino C could have killed them as well. Yeah. I don't think we will ever know, right? What's interesting is that most of us have 3% of our genome from Neanderthals, right? And some of those genes actually are risk factors for severe COVID. So they gave us a gift, right? We mated with them. So now Homo sapiens has got 3% Neanderthal DNA, and we wiped them out. So they're like, screw you, I'm giving you a COVID susceptibility gene. Hmm. Hello, Bad Cat. Welcome. You could always watch it again. Ah, shingles. Okay. So that's what you had, burning pain for 6 days. Yeah. Can be bad. Yeah. Sound effects. Whoosh. Whoosh. You got to have sound effects, right? Dagfin wants to know, is the preferred entry of SARS-CoV-2 a result of whether TMPRESS2 is available or not? Or is there any selection mechanism? No, my understanding is, so the virus binds to a receptor, and then TMPRESS is there, and boom, boom, you have fusion at the plasma membrane. But if TMPRESS is not there, then the endocytosis happens pretty rapidly. So the cell surface is always turning over by endocytosis. Little vesicles are always pinching off. And so if the virus doesn't fuse at the membrane, it gets endocytosed. That's the way it's controlled. Logotic is looking up fungal viruses. Look it up and tell us what you find. Brandon, how do RNA viruses evade the C-gas sting interferon response? Okay, so this is a response to DNA in the cytosol. So it's a response to DNA viruses, but some RNA viruses, when they replicate in cells, they cause breakdown of the mitochondrial membrane, and the mitochondrial DNA gets out, and that stimulates the C-gas sting interferon response. So that doesn't answer your question. I'm just laying out the possibilities. Now, I don't know. Let's look it up. Because, they have to, even those RNA viruses that damage the mitochondria, they have to evade it. So they can block C-gas activation. So C-gas is activated by by DNA. So maybe they can make a molecule that blocks that. They can degrade C-gas. They can target it for degradation. So dengue virus NS2B is a protease that degrades C-gas. Hepatitis C virus NS4B resists CGAMP stimulation. So there are lots of mechanisms. Well, thanks for asking. That's really good. I like that. Dorothy wants to know if you could reduce your susceptibility to virus infection by changing your diet to make your body less acidic. No, you wouldn't want to do that because your body's pH is nicely balanced, and even small changes can be dangerous. And anyway, you'd have to make the intracellular environment less acidic. Now, Dorothy, there are some drugs that make the endosome less acidic, like hydroxychloroquine and others. So hydroxychloroquine is approved for malaria, but it can inhibit the replication of some viruses by preventing acidification of the endosome. chloroquine is another such compound, hydroxychloroquine and chloroquine, that prevents acidification. So if you have, I don't think those drugs are approved for virus infection, but the idea would be if you have, in cells in culture, it works. You can add the drug to cells in culture. It makes the endosome less acidic, and so the viruses don't get out. But none of these are approved for human use. But that would be the idea, right? That you could do that. You could have virus infection, you take a pill that reduces your endosome acidity for a while. Yep. Frankie says a Japanese lab even found a virus that steals capsid from a different virus. Well, there are satellite viruses that need capsids from helper viruses. They don't encode their own capsid, right? Visto asks, I wonder how many genetic flaws in humans are survival factor selected by viruses. There probably are. So, the Delta 32 mutation in the CCR5 gene that makes people resistant to HIV. So that's a selection pressure there. But what originally caused that, we don't know. But you can imagine that those people survive HIV infection, so they're selected for. So yes, I'm sure that's happened many times, and I can't think of any other examples. But for malaria, heterozygous sickle cell is protective against malaria, and that's not good, right? But it's maintained in the population because, especially in areas with a lot of malaria, it makes you survive. Vanity says experts exist so laymen don't have to figure it out. Well, they couldn't. You need too many years to become an expert, right? And laymen can ask the experts. They can buy a book and read it. How do viruses work? Buy a book and read it. You're not going to figure it out on your own because you're going to be wrong. It's ironic that RFK Jr. figures it out. He may become an expert. Their anti-expert argument is just so stupid. It is. Basil Brush said boom boom. And Laura thinks it's Andrew Dice Clay. I don't know. I picked it up somewhere. Kang asked if some French researcher used the wrong cell line. Yeah, they used Vero cells. That's where it came from, a French lab, yeah. In Marseille, I believe. La Marseillaise. Ray's wants to know, what core science classes do you recommend for truly understanding virology, microbiology, biochemistry, genetics, organic, orgo? Let's see. Well, a microbiology class, they usually have some virology. Well, you got to take my virology course, okay? It's really good. It's free online at YouTube. Biochemistry, genetics, orgo for sure. And if you want to understand everything about science, learn thermodynamics because it makes everything make sense. I never had a good grasp of it, but I feel that if you could master thermodynamics, you would master all of biology because you understand why things happen. Doreen, hello. If the felon stays awake for 3 bullet points, he knows more than anybody. Yeah, right. But he'll forget it in 5 minutes, right? Didn't the state of Oklahoma purchase a gazillion doses of hydroxy? I don't know about that, but Dr. Oz purchased a lot of hydroxychloroquine because he thought he was going to make a killing on it. Freaking selfish people who just want to enrich themselves, right? hate it. I really despise that. No, not hate. Hate is too strong. I despise it. I really do. Yeah. Pandemic was a marketing opportunity. Sell anything as the cure and make a lot of money. It's disgusting behavior. Frankie says cryo-EM can be darn hard. Some proteins don't want to stay associated with their partners on ice. Some proteins like to orient in only one way. Some proteins, they just hate you. from someone who has experience, you see? Yes. I don't know. I never did cryo. All I know is that Jason McClellan solved the spike structure in 6 weeks in the beginning of 2020, which I always thought was amazing. Hope you let Amy know that we care and worry. Okay, I will let her know. Bio Nerd Genevieve. Hello from Orono, Maine. I wanted to let you know that you and Dixon inspired me to go into biomedical science. Today I got to name a bacteriophage. How cool. I bet you're in the C phages program. That's very cool. And I'm glad that we inspired you, and Dixon in particular would love to hear that. Very Nika Privyet. Unfortunately, you missed most of it, but you can always watch it again. Rip de Comp is also saying hi to Dr. Rosen. Oh, you were saying hi if she were listening. That's right. That was your earlier comment. That's cool. Vanity says, according to 23andMe, I have more Neanderthal DNA than 99% of the other 23andMe participants. That's interesting. Is there any evidence, Bobby writes, Paxlovid isn't as effective anymore with current strains? No. It still is working. I'm pretty sure that Daniel has cited some of these recent studies. Yeah. Very Nika says 3C in Moscow already. Missed Vincent and the chat, but glad we'll see cool stuff from all the conferences. Dorothy writes, but remember, we do not all have the same genes. Almost half of Neanderthal genome is still walking around on Earth today. Is that right? It's not the same 3% in everyone? I don't know. I haven't looked at it that well. Jeff doubts that Homo sapiens killed off Neanderthals. Their small clans and low birth rate, along with a changing climate, increasing grasslands, led to their extinction. Okay. It's not my field. I don't know. Brandon remembered that sea gas senses nucleic acids. It's okay. It does. Dagfin asks, does that mean that entry can happen through the endosome pathway in a temperus expressing cell if the spike binds at a site where the temperus is temporarily absent? Could, in theory. I don't know that happens, right? Because I don't know how much temperus is on the cell surface. That's a good question, though. It's a dog-eat-dog world. Mushrooms get mycoviruses. Everybody has viruses. Yep. Very Nika asks, it's considered okay to get vaccinated when you have a mild infection. I take it our immune system is okay with creating 2 immune responses at once. Daniel always says, if you have an illness, you should wait until you're better, until the fever's gone and you're feeling better. But if it's mild, I don't see why it would be a problem, right? Could be a mild immunosuppressive infection. Unlikely. Then it wouldn't be mild, probably, right? But in general, the last times I've been vaccinated, they don't ask me, do you have a cold or the flu or anything? They don't ask anymore. I guess you can tell if nobody's sniffling or sneezing or coughing. But let's look it up. Can I get vaccine if I have a cold? Yeah, it's good. You can get with a mild illness. Oh, yeah, the gut microbiome has a significant effect on the immune system. Get this, we're doing a paper tomorrow on TWIM. So, if you don't sleep well as you age, you're going to get frailty. There's a specific definition of frailty. And the poorer quality your sleep is, the more frail you're going to get. So they did a study to know, is there a correlation between the microbiome and frailty? And in fact, yes, there's certain bacteria that correlate with sleeping poorly, and it has to do with pyruvic acid metabolism. So how can I sleep better? Do I need to take probiotics? Maybe, yeah. Will the gin and tonic reduce endosome acidity? No. But look at what Nika says. Don't try and change your pH. Anyone who promotes alkaline drinks and stuff is a grifter and promotes misinformation. In case anyone wants a cool Russian word, I present alkali sholok. Probably sounds funny to non-Slavic people. Let's see. I think that we have similar genes from Neanderthals, having to do with skin, hair color, immune responses, diabetes, susceptibility, Crohn's disease. Some are beneficial and some are not. So I think it's the same set of genes that everybody has. Steve says, I've read even a mild COVID can cause brain and organ damage, immune system dysfunction, and reinfection. No, it's not true. I mean, mild COVID can cause long COVID, right? In a fraction of people, but not everyone. So brain and organ damage. So there are neurological symptoms. There are gastrointestinal symptoms. Yes, and that can so you're talking about long COVID. It's probably 10% of the people who have a mild COVID can get long COVID. So yes, that is correct. Yes. Sorry. Oh boy. If the endosome becomes more basic, would it have some downside? I think so, because a lot of recycling of materials in the endosomes requires low pH. So you'd be messing with that. Yeah, it can't be good. So you could. That's probably why the acidification inhibitors are not approved as drugs. Hydroxychloroquine, well, it's improved as an anti-malarial, but has side effects. Ripticomp, human birth because of viruses and not an egg birth. Yes. So the placenta is made possible from a retrovirus gene. The retrovirus integrated into our and other mammals' genomes many years ago, millions of years ago. And the spike gene basically was repurposed to build the placenta. So yes, we are viral. Viruses are us. Immunology is essential for virology. Well, it depends what part of virology. So there's a part of virology where you just study the virus getting into a cell in cells and culture. You study the virus uncoding, binding receptors, reproducing its genome, making mRNA, making proteins. You don't need to know immunology for that. But today, much of virology, it doesn't deal with that anymore. The focus has shifted to how viruses make disease. And yes, for that, you need to know immunology. And that's why we do so many papers on TWIV now that have an immunology component. Yeah. Certainly good to have the fundamentals down: chemistry, physical chem, thermokinetics, organic, everything else falls into place thereafter. Yep. Elizabeth says, I think the head of the French lab had his entire body of work questioned. Yes. Yes, he's been, many things he did were wrong. Yep. Yep. Thermodynamics and quantum mechanics are the foundation for everything. Luna's nephew is doing molecular biology and genetics. Excellent. BioNerd, I am indeed in C phages. I named the phage Power Ranger. That's awesome. BioNerd Genevieve, love it. Cryo works well for some proteins, including a lot that crystallography struggles with, but it still has quite some limitations in size, right? They have to be a certain size. If they're too small, they won't work, right? I've recently seen a comment that Russia's developing an anti-cancer vaccine. Well, there are already cancer vaccines: the hepatitis B virus vaccine and the human papillomavirus vaccine. There are also some cancer vaccines that we talked about last time. I forgot what they are, but those are 2 virus-caused cancers. So I don't know what Russia's doing, but why not, right? Josh, ACAT at Princeton studies Neanderthal genes in modern humans. Okay, well, I don't have a podcast on human genetics, unfortunately. Otherwise, I'd have him on. Dagfin says, being vaccinated while having an ongoing infection could result in poor immunization. Depends, right? If the infection is mild, I would say a raging flu, yeah, you don't want to get vaccinated. If anything, so you don't infect the vaccinator. But it may also interfere with the immune response. But I think a mild infection is not a problem. Miss Bluescan looked for Novavax everywhere. Couldn't find it. Well, yes, that's the story. Nika's going to be so frail. You got a bad microbiome. Well, listen to TWIM and we can tell you what bacteria you should have. The 117-year-old woman who recently died had the gut biome of a young person. There you go. There you go. Arizona Governor Doug Ducey produced, under governor, 1 million doses of hydroxychloroquine. It's disgusting that people want to just enrich themselves on the misfortunes of others. Oh my gosh. Brandon says, I had a thermodynamics is real moment when I was running kinetics experiments in undergrad. I had an outlier that was a wrong addition volume in my notes, fixed the error, and my second went to 1. Cool. Miss Blue Ocean takes hydroxychloroquine for Sjogren's. Took a 6-month hiatus and realized that it worked because I've been in full body pain and it's awful. Longevity is mostly about genetics. She had young telomeres. I don't know. The microbiome controls an awful lot, Nika. Gregory, thank you for your contribution to science communication. Really appreciate it. Viruses, Luna, the other nephew is doing physics. Wonderful. I love it. Yeah, it's a different kind of cancer vaccine, one you give when you already have cancer. There you go. Novavax arrived at Laurie's pharmacy today. All right. That'll do it for another. What are we at? Oh, office hours. Just kidding. Thank you to our moderators. Who did we have? Tom, Vanity Nutrition, Les, Barb Mac UK. I think I got everyone. Thank you so much for moderating. We appreciate it. Thank you all for coming. I thought maybe you wouldn't after 3 weeks, but you missed it. So that's cool. It starts at 8 p.m. Eastern. In fact, next week we will be back. Next week is, well, I don't even need to look at my calendar for this. It's an easy October 8th, 8 p.m. Eastern Time, for more exciting virology and other sciences and other things as well. So, folks, thanks for coming tonight. Really love chatting with you. If I didn't answer your question, bring it back next week. Until then, stay curious and stay safe. Good night.